Hello and welcome back. At the end of last video, we were doing some multiplying our complex numbers. And there's a special time when multiplication works really well, and that is when we are multiplying by the conjugate. So the conjugate of a number a plus bi is a minus bi, and vice versa. So the conjugate of a minus bi is going to be a plus bi. Essentially, we just switch the sign in the middle to the other one. So for instance, if I have 1 plus 2i, the conjugate is going to be 1 minus 2i. If I have 3 minus 4i, the conjugate will be 3 plus 4i. And when we see numbers that don't have a that aren't going to be complex in the sense that okay, so this is more of an imaginary number, this is more of just a real number, what would the conjugate be? Well, we can always think of 6i as being 0 plus 6i, and now we've got a real part and imaginary part, so this just becomes 0 minus 6i, which is just the same thing as negative 6i. So essentially, whatever the imaginary part is, you switch the sign in front of it to get the conjugate. So here, 10 is the same thing as 10 plus 0i, which if I take the conjugate of 10 plus 0i, it's going to be 10 minus 0i, but who cares if I'm subtracting 0i, 0 times anything is 0. So this is still just equal to 10. And you can see that the same pattern holds. We took the imaginary part of this number and made it negative. Since there's no imaginary part, nothing changes. It is its own conjugate. And the reason why this is nice is the following. We can multiply these, and we'll see something rather nice pop out. So let's multiply this. So we've got, so FOIL, we'll start with the first ones. So 1 times 1 is 1. We'll take 1 times negative 2i, which is going to be negative 2i. We've got 2i times 1, which is going to be 2i. And then we have our our last terms. 2i times negative 2i. And as we simplify this, 1 is just 1. But what you'll see is I've got negative 2i plus 2i. Well, negative 2i and plus 2i are going to cancel out. And the only thing that I have left is back here. So I've got a 2 times the negative 2, so that's going to be negative 4. But I've also got an I times an I, which is negative 1. It's going to be 1 plus 4, which happens to be 5. Let's do the same thing down here. We've got a few bigger numbers. So I've got the first terms, which is 10 times 10, which is 100. Then I've got 10 times 6i, so it's going to be 60i. And then I've got negative 6i times 10, so it's going to be negative 60i. And then in the back, I've got negative 6i times 6i, so minus 6i times 6i. And again, you'll notice that same thing happens. 60i and negative 60i, these guys cancel out. So I've got 10, and then back here I've got minus 6 times 6 is 36, and then I times I is going to be negative 1. So I get 100 plus 36, which is 136. And let's do this one so that we can see exactly what pattern is happening here. If I take the first terms, that's a times a, so that's a squared. If I take the first times the last term, so that'll be a times negative bi. I've got the inner terms, so this is going to be a times bi. And then I've got the last terms, bi times negative bi. And this is a squared. And then I've got a times negative bi plus a times bi. This guy has a negative sign, this guy doesn't. They're the same except for the negative sign. So guess what happens when we add them together? They cancel out. And then I've got b times I times negative b times I. So that's negative b squared times I squared. But I squared is negative 1, so I just get a squared plus b squared. And this is the trick. What you'll notice is that this number is entirely real. No imaginary part. So if we want to get rid of some imaginary numbers, we can take them times the conjugate, and it will simplify very nicely. So we can write the following in standard form. Standard form is also called rectangular form. And for rectangular form, and all this means is I've got my real part plus my imaginary part. So when I look at this guy, I see, oh, I've got 1 plus 3i divided by 2 minus I. That doesn't look like a real number plus an imaginary number. So I'm going to have to make this into a real number plus an imaginary number. And the thing is, on the bottom here, I've got my 2 minus I, and that makes this hard to work with. But you know what? If I multiply by conjugates, I can make numbers real. I can make them into real numbers. So here, when I see 1 plus 3i over 2 minus I, what I'm going to do is I'm going to take the top and the bottom, and I'm going to multiply by the conjugate. Whatever I do to the top, I have to do to the bottom, just to keep everything equal. So on the bottom here, I've got 2 minus I times 2 plus I. That makes this a real number. And in fact, I know exactly what number it is, because it's a squared plus the b squared. So this is going to be a squared, so that's going to be 2 squared, which is 4, plus b squared. Well, b is the number in front of the I, which is 1. And that's it. So the bottom simplifies very, very nicely. 2 times 2 is 4, 1 times 1 is 1, so I get 4 plus 1 on the bottom. The top is going to be a little bit more effort. So I'll have 1 times 2 is 2. If I FOIL, then the outside terms, 1 times I is I. 3i times 2 is 6i. And then I'll have 3i times I. So again, if I start simplifying, on the bottom I've got 5. And then on the top, my 2 imaginary terms, I and 6i, I'll write that down at the back. At the front, I've got my 2, and I've got 3i times I. Well, I times I is negative 1. So that's going to be negative 3. And I'm nearly done. So 2 minus 3 is negative 1, plus 7i over 5. And I have to write this as a real number plus an imaginary number. So I'll have my negative 1/5 plus 7/5 I. I'll just divide both of them by 5. And there you go. So the trick, multiply by the conjugate. And once we do that, everything becomes real on the bottom of the fraction, so I can simplify it quite nicely. So here, I've got 7i divided by 3 plus 2i. Again, I don't like having those imaginary numbers on the bottom of the fraction. So what I'll do is I will multiply by the conjugate. And then whatever I do to the bottom, I have to do to the top. So here, on the bottom, again, we can simplify this quite nicely. So 3 plus 2i times its conjugate is going to be 3 squared, which is 9, plus 2 squared, which is 4. Easy peasy. All we have to do is recognize that these guys are conjugates. On the top, I'll take 7i times 3, which is, if I could write, 21 times I. And then I'll have 7i times negative 2i. And again, we can simplify this down. So we've still got the 21i there. On the bottom, it'll be 13. And then I'll take 7 times negative 2 is negative 14, times I, which is negative 1. So this becomes a 14, and I like to write the real number up front, just for no other reason than it's a little bit nicer and easier to read. 14 plus 21i, and then on the bottom we've got 13. So we'll split this apart into 14 divided by 13 plus 21 divided by 13 times I. And there we go. One last one, and this one is maybe a little bit silly because of the following. I've got an I on the bottom of my fraction here, and the thing is, I could multiply this by the conjugate, but it really isn't necessary. I think the easiest way to turn this into a real number would just be to multiply the bottom by I, and then I can take the top and I can multiply that by I as well. So I don't have to multiply by exactly the conjugate here, because I can make the bottom of this fraction real just by multiplying by I, and it's maybe a little bit simpler than thinking about things in terms of the conjugate here. So if I just multiply the bottom by I get negative 1. So all I'm going to be doing is multiplying by negative 1. The top, I'll have 6 times I, and then over here I'll have 10 times I, but I times I is negative 1. So this just becomes a negative 10. And then when I divide both of them by negative 1, it becomes negative 6i plus 10. And just because I'm being a bit pedantic, I'll put this with the real number out front. So again, we don't always have to multiply by the conjugate. If it's simpler to do so, say like here I just have an I can multiply by I and make everything real anyway. And I think I will continue in the next video when we will look at complex numbers as vectors.